The construction industry is massive, and it accounts for between 4% and 8% of the US GDP. And despite its size and economic impact, labor productivity lags well behind other industries. For example, in the last 3 years, only a quarter of projects came within 10% of their original schedule. A University of Michigan study shows that construction workers spend an average of 18 to 19% of their workday idling because of holdups like searching for the tools they need.
What we face is our workers will have to leave their work area, for instance on the 3rd floor, and walk downstairs to the 1st floor in order to retrieve a tool. There's lost productivity and time and efficiency while they're away from the job, as well as people who may be waiting on them, so you lose time and productivity for several people during that time.
You know, the construction industry struggles with maintaining high labor productivity rates. One factor is providing workers with reliable and immediate access to the hand tools they need to build work. Getting our hands around that issue as an industry is crucial to increasing productivity. I believe dependable, easy-to-use technology, including robots, will be vitally important to the future of construction.
After I heard about this problem with labor productivity and tool usage at my summer internship, I had an idea. And when I ended my internship, I took this idea to our capstone program at Texas A&M, and we got a team together to act on it. When design began, the first step was actually defining the industry problem and understanding the need of the individual customer. And to gain perspective, we surveyed folks in different construction disciplines and asked questions about tool storage and usage on work sites. And what we found was 75% of our surveyed users experienced frequent interruptions in their work from moving tools from one place to another.
We boiled our primary customer needs down to dealing with tool inaccessibility and tool misplacement. And the design concept we created to address this stores tools like a normal toolbox, follows a worker on its own, and then keeps track of the tools. While there are current technologies that focus on tool inventory or on worker tracking, they're kind of confined to their specific categories. And our competitive advantage will take these functions and put them together into a more holistic solution. Knowing that a full-fledged, market-ready product was beyond the scope of the 7 months we had, we honed in on making a proof-of-concept prototype named AutoTool.
Our prototype is centered around 3 main technologies: LiDAR, vision processing, and RFID. The SICK TiM 781 allows a robot to see obstacles in a 270-degree field of view, while the onboard camera will track users with fiducials. The SICK RFU610 identifies tools with passive RFID tags, and while these sensors are all used in construction, our secret sauce is using a robot operating system to integrate them all into a single coordinated solution. From a user experience standpoint, we designed for modularity to account for a wide variety of tools and tasks on a construction site. And since many workers use buckets to carry their tools, the AutoTool has a sleeve that fits a regular 5-gallon bucket. With this, any worker can put their bucket in with tagged tools and be ready to go.
AutoTool's entry into construction promises a strong impact on labor productivity. If we go back to that 18 to 19% idle time and think about a company with 1,000 workers, eliminating half of that downtime would add up to around $3 million in savings in a year, and getting that time down to a third of what it is would be about $4 million. On top of that, you have replacement costs that are avoided from reducing tool loss, which is a $1 billion issue in itself. To measure these industry expectations, we will introduce our minimum viable product to workers on local infrastructure projects and then measure their downtime per day and percentage of tools being lost. With this data and with future customer feedback, we can then start tackling things like rough terrain or even going up flights of stairs. Our current prototype lays the foundation that we need to take automated tool carrying to an implementable and a marketable level in the future.
AutoTool is a groundbreaking proof of concept that has made us say, hey, we can use technology and automation to innovate on tool storage as we've known it. The future of the AutoTool offers productivity and convenience in ways that before seemed out of reach in the construction industry. Wherever the future of tool storage is headed, AutoTool will be right alongside it.